Good morning, my dear students. My name is Twayna. I am currently available at the Hamlet Tuition Center, Brahmatal, Kathmandu. If you want to contact me, it is 9849135739. I am also available at Kumudini Secondary School, Kalimati, Kathmandu. My dear students of grade 8, this is your science class, and in our science class we have been discussing about the lesson electricity, isn't it? And in our previous class we discussed about different types of sources of electricity. Yes, and today we are going to discuss in detail about the cell. Okay, this is not a cell from biology. Okay, this is a cell from chemistry or physics in that matter. Okay, electric cell. Actually, we have already described about electric cell. These are the devices that convert chemical energy into electrical energy. Yes, electrical cells are the devices that convert chemical energy into electrical energy. You can see all different models or all different brands of cells here. Okay, in common language, in general language, we also call them batteries, isn't it? But that is just a wrong gesture, because battery is a group of cells. When number of cells are connected in series combination of parallel combination, then only it is called battery. Okay, however, the single unit is known as cell. Okay, the single unit is known as cell. Well, there are two different types of cells. You definitely know them. Okay, primary cells and secondary cells. Primary cells means non-rechargeable batteries. Some batteries or most of the batteries cannot be recharged. Okay, that means the chemical reaction which takes place within themselves is non-reversible. Okay, let us suppose that a chemical reaction takes place as A plus B. A battery or a cell contains A and B, two chemical substances. Okay, and when they react, they form a product. Let's say, okay, let me give it okay, they form a product such as C plus D plus electrons. Okay, now this is the electron which is supplied by the battery. Yes, so as you keep on using your battery, this reaction keeps on going. It keeps on going. Yes, and finally when your battery is dead, it will have only C and D left. Okay, until it has A and B chemicals remaining, it will keep on producing electrons. Yes, and these electrons are supplied to you by the battery, and at the end, when all A and B are finished, the battery will only have C and D. Okay, however, by supplying this C plus D with electrons, if you can recover A plus B, then it is rechargeable, because by supplying electrons means by supplying electricity, you are able to reverse this reaction. Yes, when battery is working, C plus D is formed from A plus B, and while recharging, C plus D will be reactant and it will form A plus B, and after 100% of C plus D has been converted to A plus B, your battery is fully recharged, and then once again you can continue to use your battery in the same fashion, because your battery is full of A plus B. Okay, however, in some cases, in some chemical reaction, this does not occur. Okay, in some chemical reaction, this does not occur, or it cannot happen. There is this reaction is irreversible. In that case, once A and B are finished, the battery is finished. There is no way of using it again. Okay, so this kind of battery in which the chemical reaction is irreversible and cannot be recharged, they are called primary cell. And this type of battery whose chemical reactions are reversible means it can go back as well. Okay, it can go back as well by using electricity. They can be recharged, and such batteries are known as secondary cell. Okay, so there are two types of cells, primary cells and secondary cells. Primary cells cannot be recharged, secondary cells can be recharged. Okay, like here you can see this battery, it says it's alkaline. Yes, alkaline batteries are mostly rechargeable. Okay, these alkaline batteries, energizer batteries, these are mostly rechargeable. However, this everyday battery, okay, and other batteries which are found in market, they are non-rechargeable. And this diagram you can see, this is a battery charger. This is a battery charger. Okay, it is connected to source of electricity, and it supplies electricity or electrons to the battery, and reaction inside the battery is reversed by that electricity. Okay, not just this, the batteries in your mobile, the batteries in your laptop, they are also rechargeable. That is why you can charge your mobile again and again. You can charge your laptop again and again, and you can use it again, isn't it? So these are also the examples of secondary cells. Okay, now let's go to a simple cell. Simple cell is an example of primary cell. Simple cell is an example of primary cell, and it is the cell, it is a pioneer cell which was discovered at a very long time ago. Okay, this is the first cell to be discovered. Yes, and it has the simplest structure. It has simplest structure, or it is the simplest device that produces electricity by chemical reaction. Okay, even you can make it at your home. Okay, all you need to construct a simple cell is an insulating device or insulating vessel, or in this case you can use a plastic cup or plastic mug, or you can use glass cup. Okay, anything that is not conductor you can use, and that container is known as voltmeter. That container is used as voltmeter. Inside that voltmeter you must keep sulfuric acid. Okay, sulfuric acid if you cannot find sulfuric acid on your own, you can get the solution of sulfuric acid at any shop. Like the shop which sells you electrical goods, they also sells you this dilute solution of sulfuric acid. They call it battery water. Okay, they call it battery water, the water which is used in battery. Okay, and then you need a copper plate and a zinc plate. If you have this much device, you can easily make a simple cell at your home. What you need to do is, in a different container, if you are going to use pure sulfuric acid, then you need to add around 100 ml, or basically 99 ml of water. Okay, you need to add around 99 ml of water. Yes, because you need to make solution of acid for this purpose. Yes, you need to make solution of acid for this purpose, and you can, while doing that, you cannot add water in acid. That will cause fire hazard. If you pour water in acid, that will cause fire hazard. Okay, so that is why you must first take water, and in that water, this is 99 ml of water. Yes, 99 ml water. In that water you have to add 1 ml of sulfuric acid, H2SO4. Okay. Uh, okay, this is how you make dilute sulfuric acid. Okay, you can make it in different concentration as well, like adding 10 ml of sulfuric acid in 90 ml of water. That also you can do. Okay, or in this case I'm using 1 ml of sulfuric acid to 99 ml of water, because being a student it could be hazardous to handle higher concentration. Actually this much concentration of sulfuric acid will produce very small amount of current, but for learning purpose that is also okay. Okay, if you want to produce more or higher amount of current, then you can use the combination as 90 ml of water to 10 ml of sulfuric acid. You can use this combination. Okay. Okay, anyway, however you cannot go beyond this concentration, because if concentration is increased rapidly, then instead of producing electricity, the acid will start to react with copper and zinc themselves. Okay, then there won't be electricity and there will be degrading of components as well. Okay, that's why don't increase it beyond 10 ml of H2SO4. Okay. Okay, so after mixing it properly, you pour this solution in this vessel or voltmeter, and then dip a copper plate and zinc plate, connect these two plates with a piece of wire to the bulb. The bulb will glow. Understood? This is the simple cell. This is the structure of simple cell. Now take note of it. Construction of simple cell. A non-conducting container is taken, which is called voltmeter. You know, non-conducting means it must be made up of insulator. A dilute solution of sulfuric acid is prepared by adding 1 ml of concentrated sulfuric acid in 99 ml of water. See, dilute means norm. Okay, dilute means norm, which has been pacified by adding water. Otherwise, sulfuric acid is very detrimental. It is very hot. Even though you do not heat it up, it is very hot. If you happen to touch sulfuric acid with your skin, then it will cause burning pain. Okay, it will burn your skin. Yes. Okay, so it is extremely detrimental to use sulfuric acid. You must be extremely careful while using sulfuric acid. Okay, that is why it must be diluted before use. Diluted means by adding water it is weakened. Okay, and then the solution is added to the container. A zinc plate and a copper plate are connected to a piece of wire. Zinc plate with red wire and copper plate with blue wire. It is better to use color code while doing wiring so that you don't get confused. Red means danger, blue means no danger, peaceful, isn't it? So red wire is attached to positive terminal. Okay, red wire is attached to the terminal with positive terminal. I guess I made it opposite here. Yes, zinc plate is with blue wire, sorry for my mistake, and copper plate with red wire. Okay, red wire is connected to positive terminal. Yes, and copper plate acts as positive terminal in simple cell. That's why copper plate is connected to red wire, and zinc plate acts as negative terminal, and so it is connected to blue wire. And then both the plates are dipped in dilute sulfuric acid, and a bulb or galvanometer. Galvanometer is a device which detects even smallest amount of current. Okay, they are connected to the wires. Red wire is connected to positive terminal and blue wire to the negative terminal of the bulb. Okay, by doing so you can see that the bulb glows. Okay, you can see that the bulb glows. Yes. Okay, now working mechanism of simple cell. This part is very important. Actually, I suggest you that first of all you pause the screen and copy this all. Okay, let's go through this. How does a simple cell works? I already told you it is through chemical reaction that simple cell produces electricity. Now a simple cell has three basic parts in which reaction occurs. One is called electrolyte, the solution which is used in simple cell, it is called electrolyte. Another is called electrodes, okay, and there are two electrodes you can see, copper electrode and zinc electrode. So these two electrodes are called anode and cathode. The electrode which acts as positive terminal, that is called anode, and the electrode which acts as negative terminal is called cathode. Okay, so there are three spots in which chemical reaction occurs: electrolyte, cathode, and anode. Okay, now you have in electrolyte you have sulfuric acid. Yes, so what happens is when you add sulfuric acid in water, actually it breaks down, it undergoes ionization. It is made up of hydrogen and sulfate ion, isn't it? So when you add sulfuric acid in water, it breaks down to form hydrogen and sulfate ion, that is known as ionization. See the reaction, H to SO4 gives H plus and SO4 minus minus. Sulfate has double negative charge and you have two hydrogen atoms, so it forms two ions of hydrogen, and this double arrow means, double direct, double faced arrow means this reaction is reversible. Okay, while sulfuric acid breaks down to form hydrogen and sulfate, at the same time hydrogen and sulfate also combines to form sulfuric acid. Okay, so you can say that 50% of sulfuric acid is in this dissociated form. Okay, this is a reaction that occurs in electrolyte. Now let us go to the reaction that occurs in anode. Anode means copper plate, isn't it? Anode means copper plate. Now, okay, since that sulfuric acid breaks down to form hydrogen and sulfate, yes, among them hydrogen moves toward copper plate and sulfate moves toward zinc plate, because you know that electrical potential, you know anything about electrical potential? Okay, electrical potential is the tendency to accept electrons. Okay, electrical potential is tendency of an element to accept electrons. Okay, and since electrical potential of copper is less than hydrogen, electrical potential of copper is less than hydrogen, when hydrogen approaches here, it indeed takes electron from copper. बुझेन? बुझेको छ कि छैन हेर न, यो कपर को इलेक्ट्रिकल पोटेंशियल के छ? थोरै छ है, हेर इलेक्ट्रिकल पोटेंशियल अफ कपर यो के छ त लेस देन हाइड्रोजन हो। कपर को इलेक्ट्रिकल पोटेंशियल थोरै छ, थोरै छ भन्नुको मतलब इलेक्ट्रोन ले कसलाई प्रिफर गर्छ त? यदि इलेक्ट्रोन ले कपर र हाइड्रोजन दुईटा मध्ये एउटालाई चुज गर्नु पर्यो भने इलेक्ट्रोन कोसँग जान्छ, कसलाई प्रिफर गर्छ त? इलेक्ट्रोनले इलेक्ट्रोनले हाइड्रोजनलाई प्रिफर गर्छ। किन? हाइड्रोजनको इलेक्ट्रिकल पोटेंशियल धेरै छ है। त्यसैले जब यो हाइड्रोजन ओके जब यो हाइड्रोजन चाहिँ मुभ गरेर यो कपरको नजिकै आउँछ नि, कपरको नजिक आएपछि यो कपरमा भएको इलेक्ट्रोन के हुन्छ र? यिनीहरू कपरसँग नबसेर हाइड्रोजनसँग आउँछ। इलेक्ट्रोन्स लाइक हाइड्रोजन बेटर देन कपर है। अनि जब कपरको इलेक्ट्रोन हाइड्रोजनमा आउँछ, यो हाइड्रोजन के बन्छ त? H प्लस र इलेक्ट्रोन E माइनस एट्याच भएपछि यो एउटा प्रपर हाइड्रोजन बन्छ नि, हैन? हो कि हैन? यसलाई मैले यसलाई हटाइदिएँ हैन, बन्छ के त भन्दाखेरि हो त्यो इलेक्ट्रोन पाएपछि अब यो हाइड्रोजनको चार्ज न्यूट्रलाइज हुन्छ, जस्ट हाइड्रोजन हुन्छ हैन। अनि एट द सेम टाइम यो कपरमा हेर त, यो कपर पहिला न्यूट्रल थियो, तर यसको इलेक्ट्रोन हाइड्रोजनले लिएपछि अब यसमा के चार्ज के हुने भयो त? यसमा पोजिटिभ चार्ज डेभलप हुने भयो के। बुझ्यो कि बुझेन? जब यो कपर को इलेक्ट्रोन हाइड्रोजनले लिन्छ, लिएपछि यो कपरमा इलेक्ट्रोन डेफिसिएन्ट हुन्छ र जति यसको इलेक्ट्रोन हाइड्रोजनले लिँदै जान्छ नि जति धेरै लिन्छ त्यति नै धेरै यसमा के डेभलप हुन्छ र प्लस चार्ज डेभलप हुन्छ कपरमा यति बुझ्यो हेर त भएको के छ कपरले दुईटा इलेक्ट्रोन कपरबाट छुट्टिन्छ एउटा कपरबाट दुईटा इलेक्ट्रोन छुट्टिन्छ है एउटा कपरबाट दुईटा इलेक्ट्रोन छुट्टिन्छ अनि त्यो इलेक्ट्रोन कसले लियो H+ ले लियो H+ ले इलेक्ट्रोन लिएपछि के बन्यो सिंगल H बन्यो हो त्यो दुईटा इलेक्ट्रोन दुईटा H+ ले नै लिन्छ नि हैन र सिंगल H दुईवटा बन्यो अनि यस्तो दुईवटा H बनेपछि यस्तो दुईवटा H बन्यो भने अब दुईटा H पनि के हुन्छ त यसरी कम्बाइन भएर बस्छ नि हाइड्रोजन भनेको डाइएटोमिक मोलिक्युल हो थाहा छ रहेछ है यसले के बनाउँछ H2 बन्छ र H2 फर्ममा यो के हो त अब दिस इज अ ग्यास नाउ दिस इज ग्यास जब हाइड्रोजन दुईवटा कम्बाइन हुन्छ इट फर्म्स ग्यास त्यसले चाहिँ बबलको फर्म गर्छ बुझ्यो यो रियाक्सन बुझ्यो है यु अन्डरस्टुड दिस रियाक्सन then you can see the overall reaction is what is happening here copper is utilized yes in reactant side you can see copper is utilized and these two hydrogens are actually the products of these two reactions so they can be cancelled out on both sides yes they can be cancelled out on both sides okay so these two electrons you can see these two electrons are produced in first reaction which are used in second and third reaction so they can also be cancelled out so your overall reaction would be in reactant side you have copper and two ions of hydrogen in product side you have hydrogen gas and copper ion see copper plus 2s plus gives H2 plus Cu plus plus okay this is how copper rod or copper plate becomes a positive terminal get it this is how copper plate becomes positive terminal see hydrogen take up its electron hydrogen took out the electron from copper got it you understand the reaction that takes place at copper that means anode see copper plate acts as anode it has lower electrical potential than hydrogen so hydrogen ions are attracted to copper plate and gain electrons hydrogen ions they gain electrons from copper in this way copper plate gains positive charge by losing electrons to hydrogen ion this is I only wrote overall reaction here okay this the last step of reaction if you like you can take out the full reaction because by taking full reaction it would be easier for you to understand okay even when I am not there to explain it you will perfectly understand it the next time the first time definitely you need explaining but the next time you can understand it on your own okay that is the reaction happening in anode now let us discuss the reaction that occurs at cathode okay let's see here okay at cathode we have used zinc yes and electrical potential of zinc is higher than hydrogen itself that is why hydrogen does not move toward zinc indeed sulfate ions they move toward zinc okay sulfate ions move toward zinc and the zinc at the same time zinc also forms zinc ion and electron each zinc ion releases 2 electrons okay each zinc ion releases 2 electrons and while releasing electrons okay let me Zn okay so you understand this okay this is zinc okay let me change the color of zinc shall I okay butterfly which color do you like Okay, this is zinc ion. What happens? A zinc atom gives off 2 electron and forms zinc ion, just like copper. See, just like copper, zinc also gives off 2 electron and forms zinc ion. When sulfate comes closer, then definitely sulfate doesn't want electron, does it? Sulfate doesn't want electron. Sulfate already have excess of electrons. So instead of electron, sulfate takes up zinc. Here hydrogen wants electron, so hydrogen ions, they take up electron, leaving copper alone. But here sulfate takes up zinc, leaving electron alone. So when sulfate reacts with zinc, it forms zinc sulfate. So its overall reaction is like this. So you can cancel out zinc from here, yes, because the product of first reaction is used in second reaction. So its overall reaction is zinc plus sulfate ion. Zinc plus sulfate ion gives zinc sulfate plus electron. Zinc sulfate plus electron. So in this way, since zinc and sulfate ion, they combine each other, they form a compound, zinc sulfate, yes, and zinc sulfate is solid, which insoluble solid. Zinc sulfate is insoluble solid. It is not soluble in water, isn't it? That's why it settles down at the bottom of the container, yes. So by taking out zinc, the zinc plate builds of electron. Understood? The zinc plate builds up electron with this reaction. When a single sulfate ion approaches zinc plate, it leaves back 2 electrons. When single sulfate ion approaches the zinc plate, it leaves 2 electrons in zinc. Okay, so through this reaction, you can see that positive charge is accumulated in copper plate and negative charges are accumulated in zinc plate. So when you connect these 2 plates by using a conductor, then electrons will start to flow through this conductor like this. Electron will flow through the conductor, and if you have kept a bulb or a load in that conductor in the path of electron, then the electron will flow through that load as well. Okay, and finally through conductor the electron will reach the copper, and since copper has positive charge, that positive charge will be neutralized by electron, and next electron that also go on like that. Yes, this electron also move through the conductor. Okay, it will form a current. Yes, it will form a current that passes through the bulb, blows the bulb, and it reaches the copper. When it reaches the copper, it neutralizes one of the positive charge. This reaction keeps on going, and when all the electrons accumulated in zinc is finished up, then the battery becomes dead. Okay, and you can recharge this battery by adding sulfuric acid, because sulfuric acid is being consumed. Yes, sulfuric acid breaks down, hydrogen is consumed by copper plate, sulfate is consumed by zinc plate, and sulfuric acid is not formed again. So by adding sulfuric acid, you can recharge this battery. That's why in your inverter battery, you need to add water time to time. Yes, and that water is not normal water. That water is sulfuric acid, dilute solution of sulfuric acid prepared in this way. Understood? Any confusion? Any confusion in simple cell? As a reaction at cathode, zinc plate acts as cathode. The zinc has higher electrical potential than hydrogen, so sulfate ions are attracted to zinc plates despite the presence of hydrogen ions. So sulfate prefer zinc instead of hydrogen. At zinc plate, sulfate ions donate electrons and react with zinc, forming zinc sulfate. The electron thus released remain in zinc plate, and zinc becomes negatively charged. So formed zinc sulfate forms a mud-like substance under the zinc plate, which is known as cathode mud. Okay, cathode mud is this zinc sulfate that will settle down at the bottom of the container. Understood? Okay, so the overall reaction is zinc plus sulfate ion gives zinc sulfate plus electron. See, in this case also I have written only overall reaction. For better understanding, I suggest you copy the total reaction, all the reaction. Okay, any confusion? Okay, take this note, copy this. If you want to take note, I will pause the screen over here. Pause the screen, I'll wait. Okay. Okay, so you understand the working mechanism of simple cell. Let us go to defects of simple cell. First of all, local action. What happens in local action is that this is suppose a zinc plate. Yes, this is zinc plate, and as we have already discussed, electrons keep on gathering, keep on accumulating on zinc plate, since zinc ion is taken up by sulfate ion, isn't it? Electrons keep on gathering, and this electron, as I told you, it is supposed to travel through the conductor. Yes, it is supposed to travel through the conductor. However, if your zinc plate is not pure, it is not pure zinc, it contains impurities like iron. Okay, it contains impurities. Then these impurities, these iron, they themselves will absorb or will accept the electron, and each iron ion, each ferrous ion will take up 2 electrons. See, if the electrons are taken up by the components of or impurities of zinc plate itself, then these electrons will not go to the circuit. Okay, and once all these impurities are satisfied, only then the electrons will be able to travel, will be able to transmit through the conductor. Understood? Understood the problem? Yes. So this problem in which the action is taken in localized place, that means in zinc plate itself, since the current is flowing within zinc plate itself, this defect is known as local action. Okay, now you will understand what is written here. The zinc plate used may have impurities such as iron. The impurities have higher potential than zinc itself. So this zinc plate has zinc as well, but these electrons prefer iron over zinc. Okay, instead of remaining with zinc, these electrons will prefer iron, they will go to iron. Yes, so the electrons produced in zinc are received by these impurities, so the current will flow within the zinc plate. This defect is called local action. Yes, and it causes loss of electricity. Electricity is produced, but because of local action, the electricity is lost within itself. It causes loss of electricity, and it occurs only at zinc plate. That's why this defect occurs on cathode. Zinc plate is cathode. Okay, on anode or on copper plate, can this defect occur? No, copper plate does not accumulate electron. Copper plate simply accepts electron, simply loses electron. Copper plate loses electron. Okay, that's why this defect does not occur in copper plate. This defect occurs in zinc plate. Okay, will you forget that? Okay, zinc, this defect or local action occurs only in zinc plate. Okay, next defect is polarization. Okay, since once again look at this reaction here, you know that at the end of this reaction hydrogen gas is formed, and hydrogen gas forms a bubble. Okay, now let me represent this as a simple circle. Let me represent the bubble as a simple plain circle. Okay, this is the hydrogen bubble. Yes, and as the reaction goes on, continues on, more and more hydrogen bubbles are formed. Yes, and when this hydrogen bubble completely covers the copper plate, these hydrogen bubbles, they keep on attaching on the copper plate. Yes, so when the copper plate is completely covered up by hydrogen bubble, then what happens? like this. Okay, if this is to happen, then when hydrogen ions are formed, in this reaction, okay, let me revert the reactions, all those reactions. Yes, okay, let me revert all those reactions, because here sulfuric acid breaks down into hydrogen and sulfate. This sulfate will go to zinc plate, but this hydrogen will not be able to go to copper plate, because the copper plate is shielded by these bubbles of hydrogen. Yes, and if it cannot go to copper plate, then once all these positive charges are neutralized, will it be able to form new charges? Will it be able to form more positive charges? Because positive charge is formed because of hydrogen. When hydrogen accepts electron from copper, it forms positive charges. But when hydrogen atom cannot contact copper, then it will not form positive charge, isn't it? It will not accumulate positive charge. And in that case, even if this zinc plate is full of electrons, free electrons, even if this is the case, by connecting zinc and copper, will it cause flow of electric current? Will it cause flow of electric current? No, it will not, because there is no positive charge here to accept electron. Understood? Now this defect is known as polarization. Polarization means only one pole is active, another pole is inactive. Okay, only one of the pole is active, another pole is inactive. This defect is called polarization. Okay, see, when hydrogen ions gain electron in copper plate, they form atomic hydrogen, which combine to form hydrogen gas. The hydrogen gas forms bubble, which are bubble. Okay, the hydrogen gas forms bubble and remain at the surface of copper. Yes, when the copper plate is completely covered by hydrogen bubbles, flow of electric current stops. This defect is known as polarization, and it stops production of electricity, and this defect occurs on anode. See, these 2 points are important for differentiating. If you are asked to differentiate between local action and polarization, you can utilize these 2 points. Local action causes loss of electricity, polarization stops production of electricity. Okay, local action does not stop production of electricity, but it causes loss of produced electricity. But polarization completely stops production of electricity. And local action occurs on cathode, polarization occurs on anode. Understood? Now, how can you remove the defect of polarization and local action? Well, to remove local action, you can use pure zinc, isn't it? Okay, there are no space, so I'm going to write it like this. Okay, local action can be removed by using pure zinc as cathode. Okay, local action can be removed by using pure zinc at cathode. Okay, it can be removed by adding pure zinc, by using pure zinc as cathode. And how can you remove polarization? Okay, polarization can be removed. Polarization can be removed by using depolarizing agents such as copper sulfate. Okay, copper sulfate, what it does, it reacts with hydrogen as soon as it is formed. Okay, copper sulfate, what it does, as soon as hydrogen is formed, it reacts with hydrogen. Okay, so if you add copper sulfate in battery, then that will react with hydrogen, and the hydrogen bubbles cannot stay on the surface of the copper plate, isn't it? Okay, that is how you can remove polarization. Okay, this was for today. I told you today's class is going to be long one. Okay, if you have any confusion, feel free to contact me. In our next class, we will be discussing about dry cell. Until then, I'd like to wrap my class right here. Okay, thank you very much.